Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new session where we will study how to form the differential equation. Means we will be giving you some function, and from that function, you will be creating differential equation. So, how will it proceed? So look at this. This is the first idea. First, I will be giving you family of curve. Okay, we can have any multiple curve, and if you will differentiate the curve, you will end up having differential equation. And to backtrace the original family of curve, you need to integrate things. Okay, so this is the idea. Now, the idea is we have to solve, like how we will solve differential equation, how we will create differential equation. So there are certain steps involved which we have to understand. Okay, so question will remain the same, means I'll be giving you some family of curve and then you have to respond accordingly. So this is the first idea. First you have to count the number of arbitrary constant. Arbitrary constant means, do you remember that uh, while solving integration we used to write integration constant c. So c can take any value, so that c is integration constant, and that is arbitrary constant. So here also first we have to count the arbitrary constant. Okay, and we have to, like, suppose I will be writing a somewhere and some other place I have used another a, so both a will behave as same. Okay, means these arbitrary constants has to be independent. It is not like we will write c1 plus c2 plus c3 plus c4. It is not like that, because all things will add up being a single arbitrary constant, some k. Okay, so the arbitrary constant should be minimum. Now the next step is, first you will count the number of arbitrary constant and then you will differentiate your function that many times. Okay, so this is your second step. Now the final step is write down final equation free from arbitrary constants. So you have to remove all the arbitrary constants. Okay, suppose you have four arbitrary constants, so you will be differentiating four times. Now you know that you are having, right now you are having five equation, first family of curve, and because of these four differentiations you got four new situations. So altogether you have five situation. So you can use these five equations to write down a final equation free from arbitrary constant. Okay, if in the final situation you are not having any arbitrary constant, that will be considered as differential equation. I hope things are clear. Now for example, let's take some of the situations. Okay, write differential equation for the given family of curve y equals mx. Okay, so we got this situation, y equals mx. Now you know that x is independent variable, y is dependent variable, and we have one arbitrary constant, this m. So how many arbitrary constants we got? So right now we got one arbitrary constant. So what we will do, we will differentiate our function once. So we will differentiate with respect to x. So we got dy by dx equals m. So this was our first equation. Right now, because of differentiation, we got another equation, two equation. Now we have to write down final equation free from arbitrary constant. So what we will be doing, I will substitute value of m from equation 2 to equation 1. So we got things as y equals dy by dx x, correct? So can I write dy by dx equals y by x? So we got our differential equation done. I hope things are clear. Let's move on to the next example. The order of the differential equation whose general solution is given by this. So you have to find out the order of the differential equation, order. Okay. So order means what? How many times we have to differentiate? This defines the order. And the number of differentiation depends upon what? The number of differentiation depends upon arbitrary constant. So look at this, our equation. So we got y equals c1 plus c2, okay, cos of x plus, this is c3, okay, minus c4 e power x plus c5, this is c5, okay. Now according to this, c1, c2, c3, c4, c5 are arbitrary constant. You know that you have to find out the order. So the number of times you have to differentiate will decide the number of, like, will decide the order of the function. Now look at this. Don't you think that this is not two arbitrary constants? It is single, because suppose it is a constant, it is a constant. Don't you think you can add both of them and create one new constant? Okay, so suppose it is a, I have added both of them. Now we got cos x plus c3. You cannot manipulate this c3, okay, because this is inside the argument and you cannot change with the variable x. But look at this situation. Can I write this thing as c4 e power x and then minus c4 e power, okay. So we have, wait a moment, so we got, like, power is added, no, so base must be same, so e power c5. Now don't you think that we guys can club these two situations? Okay, so look at here. So we got a cos x plus c3 minus b e power x, okay. So look at the arbitrary constant, a, c3 and b. So we got three arbitrary constant, so we will differentiate this function thrice. Therefore the order of the differential equation will be 3. Required order equals 3. I hope things are clear. Let's switch on to the next example. So we got this situation. Finding differential equation for the system of parabola this. Now, again observe your situation. We got y square equals 4a x plus a. Now, you know that y is dependent variable, x is independent variable. We have 4. 4 is a constant. It is not arbitrary constant. There is difference between constant and arbitrary constant. Like, try to understand this part. 4 is 4. It cannot change its value. But a can take any value, 0, 4, 5, 6, 20, 30, 40, anything it can take. Okay, that this makes a to become arbitrary constant, but 4 is a constant. So if you'll observe, we have a over here, we have a over here. So if I'll ask you how many arbitrary constant do we have, you will answer, sir, it is 1. So we need differential equation. So what we will do, we will differentiate this function once, correct? So let's differentiate this function with respect to x. So can I write 2y dy by dx? We have to differentiate with respect to x. So we got 4a. Differentiation of x becomes 1, and this is constant. Constant differentiation will become 0. Now look at this. We got value of a as y by 2 dy by dx. Okay. Now what we will do? We will use this value and we will substitute here to write down the final result free from any arbitrary constant. So we got y square equals 4 times, in place of a we have to write y by 2 dy by dx, and then we have x plus y by 2 dy by dx. So this is our final equation free from any arbitrary constant. I hope things are clear. Let's switch on to the next example. So look at here. In this question, they are asking us to find out the difference between degree and order. First, we have to find out degree and the order, and then you have to find out the difference between them of the differential equation that represents family of the curve given by this. So they have already mentioned family of curve. You have to first find out differential equation, then order, then degree, then go with difference. So our function is this: a times x plus root a by 2. Now clearly you can observe that we have one arbitrary constant, that is a. Okay, so we have one arbitrary constant, so we will differentiate our function once. So let's do it. So differentiation of y square becomes 2y dy by dx. I'll be using y dash. Okay, now this is a. Differentiation of ax becomes a, and then we have constant, so constant will become 0. Okay, now let's use this value of a in the above equation. Okay, like you know that order will be 1 only. Okay, because we have differentiated once, so highest differential present in the equation will be 1. So order we got. Now we have to find out the degree. For degree we have to convert it into polynomial form, then only we can answer. So look at here. We got y square equals 2y y dash x plus root over 2y y dash by 2. Correct? So now you can play fruit ninja. Y gone. Now look at here. So we are left with y by 2 y dash, okay, equals x plus root over 2y y dash by 2. Now I will ask x to come this side. So we got y by 2y dash minus x is equal to root 2y y dash by 2. Now, to get rid of this square root, we have to do square on both sides. So we will be left with what? Wait a moment. So on left hand side, we will be having a minus b whole square. So we got a square y by 4y dash a square plus b square and then minus 2ab. So we have xy by y dash is equal to 2y y dash by 4. This thing gone. Now look at this. According to me, we got order as 1. Now look at the degree. So look at this. You know that here we will be having 16 y dash dy by dx square. Here we will get ones. Okay. So don't you think that on the left hand side, that too on denominator, we will have dy by dx square, okay, on the denominator, and that will be sent to numerator of right hand side. Over there already we have dy by dx, so that will become 3. So highest power of highest differential equation will become what? 3. Therefore the degree will become 3. We need the difference between order and the degree, so the required value will become 2. I hope the idea is clear. Okay, let's move on to the next example. Consider the family of all circles whose center lies on the straight line this. Okay, so you have circle and the center of the circle will lie on this line, means x coordinate and y coordinate of the center will remain the same. Okay, so they are talking about all the circles. So circle means what? You will have so many circle having different radii. Okay, so can I say that we will have a circle x minus a whole square plus y minus a whole square equals r square. The You know that the center will be a comma a and center is on this line, correct? And we may have different radii. So we got how many arbitrary constants? 2, a and r. So we got 2 arbitrary constant, correct? So what we have to do? We have to differentiate the function twice. Okay, so let's do it. So this is our first equation. Now let's do the differentiation once. So we got 2 times x minus a plus 2 times y minus a dy by dx, okay, and is equal to 0. For simplification I'll be using y dash. Okay, just manage. Differentiation of x becomes 1. So we got this situation. We have differentiated our function once. Now let's do the differentiation one more time. Okay, so we have 2x. So differentiation of 2x is what? 2. Differentiation of minus of 2a, 0. And then we have differentiation of 2y y dash. You know that 2 is a constant, can be taken outside, or let's simplify this way. Can I divide both side by 2 to the equation 2? We will be left with what? This and this. Okay, now differentiate. So differentiation of x becomes 1, differentiation of a becomes 0. Now y dash. So first function as it is, differentiate second function, plus second function as it is, differentiate first function. Okay, now we have minus of a y dash. So a is a constant, can be taken outside. Done. Okay, so we did the differentiation. So we got all three equations. Now what we have to do, we have to find out, like look at this. If you'll observe, over here we have only one arbitrary constant, that is a. So can I do that? Find out the value of a from here and substitute there. Okay, so what we'll do, we will find out value of a from equation 2. Equation 2. Now look at this. Can I write x minus a plus y dash minus y dash equals to 0? So we will keep a on one side. So we have a times 1 plus y dash, and we have x plus y dash. So we got value of a as x plus y dash upon 1 plus y dash. So we got our value of a. Now what I will do, I will substitute value of a in equation 3 to find out the final differential equation. Okay, so look at here. We have 1, we have y double dash, we have y dash minus a. So can I write x plus y dash, 1 plus y dash, and then we have y double dash equals to 0. Okay, now look at here. We will take LCM. So we have 1 plus y dash. Now this with 1 means I have manipulated the first component. Now second component, y double dash, and then y dash, y double dash. This is second component. Now we will be using third component. So we have y dash square, and then we will be having y dash cube. This is our third component. Now we have last thing, minus of x y double dash minus y dash y double dash equals to 0. So we got our final equation. I hope till this part you guys are okay. Okay, now look at this. If this family of circle is represented by the differential equation, this means we have to write y double dash, then y dash, and then pq, and then we have to find out combination of pq. Okay, we will do that. So we have to find out y double dash and y dash. So look at here, just focus on y double dash. So we have y double dash over here, y double dash over here, y double dash over here, y double dash over here. Okay, so can I take y double dash common? So we will be left with y plus y dash minus x minus y dash. So this is your double dash done. Now we have single dash. Now look at here, for single dash we have this, this and this. So I will take y single dash. So from first component we have 1 single dash y dash and then y dash ka square. Okay, and at the end we have 1. Yes, we have 1. So we have 1 equals to 0. Now you can compare, like they have told you guys, y double dash p y dash q plus 1 equals to 0. Now you can say that, sir, p is equal to this thing gone. Okay, p is equal to y minus x and q is equal to 1 plus y dash plus y dash ka square. So this is our p and q. Okay, now look at the option. So look at this, they have, these guys are talking about p. So who is p? P is y minus x. So option B is correct. Correct? Option B is correct. Now p plus q, p minus q. So look at here. If you'll focus on p plus q, p plus q will have all 5 terms. Nothing will vanish. Okay? Y minus x, p plus q. Y minus x is there. Wait. Y minus x is there. And then we have y dash ka square and 1, y dash ka square 1. This option C is also correct. Now p minus q. So p minus q, so you will have 4 things in minus. Correct now? Look at here. We don't have 4 things in minus. So option B and option C is correct. I hope this session is fruitful for you guys and we guys are adding some value to your preparation level. So stay connected. If you find any interesting question, please put it in comment box so that we can upgrade this playlist. See you guys in next session of MathFlix.